Good morning, students. This is Miss Williams. It is Monday, May the 4th, and today we are going to expand on what you learned last week about solving one-step addition and subtraction equations with whole numbers. This week we are going to do it not with whole numbers, but with decimals, fractions, and mixed numbers. In this video this morning, I am going to show you 6 different equations. We're going to solve 6 different equations involving fractions, decimals, and mixed numbers. And then you will do some practice on IXL and an exit ticket in formative. Here is our first equation. So the difference between this and equations that we did last week is that this particular equation has decimals in it. What I want you to think of when you're looking at this is I want you to think of a similar equation with whole numbers. And what would you do with that one? So some number, you take away 2 and you get 8. Some big number, you take away 2, and the answer is 8 after you've taken away the 2. So the answer is 10 to that. And what you actually did was that you added 2 to both sides so that you ended up, let's go back to the x, with x equals 10 by adding the 2 to both sides. So in our decimal equation, we're going to add the 7/10 to both sides. And here, these subtract 7/10 and add 7/10 makes 0. And then we're going to add the 7/10 to the 3 and 2/10 to get 3 and 9/10 as our answer. So that would be the answer to the first equation. And then, of course, you can check your work. By substituting your answer in. Always use parentheses when you substitute your answer in. If I take 7/10 away from 3 and 9/10, do I get 3 and 2/10? Yes, I do. And just to show that off to the side, 3 and 9/10, I'm taking away 7/10. 7 from 9 is 2. And there you go. All right, so that's problem number 1 done with a one-step subtraction equation involving decimals. Here's problem number 2. This is a one-step equation, again involving decimals. We have to find the value of W, and this one is pretty straightforward because we just have to add the 4/10 and the 8 and 7/10 to get the W. So in this case, all we're doing is 8 and 7/10, we're adding the 4/10, and we get 9 and 1/10. So 9 and 1/10 is W. And that would be the answer to number 2. Here's number 3. Okay, k plus 2/7 equals 3. If the fraction throws you off, think of a similar equation that has whole numbers, and that will tell you what to do. So because this is an addition equation, to solve it, we've got to find some number. When we add 2, we get 3. So something plus 2 equals 3. That's going to be 1. And the way you do it is by subtracting 2 from both sides. And you get 1 as your answer. So what we're going to do here is subtract 2/7 from both sides. And you get k equals 3, subtract 2/7. Now, going back to work we did on fractions earlier in the year, we can rewrite that 3 we could do this two ways. We can rewrite it as 2 7/7, because remember, when you take one whole out of the 3, that's the same thing as 7/7. Or we can write the 3 as the total number of sevenths that it would be, which is what I'm going to do. That would be 21/7 minus 2/7. Because remember, 3 is 7/7, which is 1, plus 7/7, making 2, plus 7/7, making 3. So that's 21/7. So this would be 19/7, which would be 2, that's 14 of the sevenths, and 5/7. 2 and 5/7 would be the answer. You can substitute back in to check. So here's my check. So k plus 2/7 equals 3. So 2 and 5/7 plus 2/7 equals 3. So that would be 2 plus, so this is 5 plus 2 over 7, which is 2 plus 7/7. And that would be correct. Sorry, I'm right down at the end of my page, but that would be 3 equals 3, which checks out correctly. All right, let's go ahead and do another, we're going to do another 3 problems as part of our video. So here is problem number 4. 5 3/10 minus 2 equals y. So you're just subtracting 2 from 5 3/10. Remember, when you're subtracting to line up decimals, that's 2 wholes that you're subtracting. So the 2 gets lined up under the 5 when you subtract, and it's 3 3/10. That one is pretty straightforward. Let's have a look at another one. Here's 5. So x plus 2/3 equals 2/3. So something, when you add 2/3 to it, you get 2/3. What can I add to any number and it stays the same? It doesn't change. Must be 0. Nothing plus 2/3 is 2/3. So this is going to be a 0. 0 plus 2/3 is 2/3. Another way you can think of this for solving is if I subtract 2/3 from each side, what do I end up with? Well, clearly I end up with 0 on the right-hand side. Okay, last problem. Number 6. So I have a variable m. I'm subtracting 8/9, and I get left with 3 7/9. So again, like we've been doing all the way along, we're going to use the opposite operation to get rid of that 8/9. So we're going to add 8/9 to both sides. So we get m equals 3 7/9 plus 8/9. And now we just need to manage that fraction, those fractions over on the right-hand side. So 7/9 plus 8/9 is 15/9. But 9/9 makes a whole, so it's really 3 plus 9/9 plus 6/9, which is 4 6 over 9. And you can simplify that to 4 2/3, which would be the final answer for that question. So it's a matter of just adding, once you've got a common denominator, you just add the 2 fractions together, and then you simplify from there. All right, there is some IXL for you guys to practice on, and some 3 problems as an exit ticket in formative. I will see you guys on a Zoom call tomorrow, Tuesday, so we will review this if you have questions. And have a great day. Bye-bye, everybody.